Good morning again, everybody. Hope you had a good weekend. As I'm sure you heard, we are continuing with this distance learning for at least 3 more weeks. All schools are closed until April 10th, so hopefully that will be it, and we will be able to return to school so you can all finish out your senior year. We are going to be continuing with 4A today. So where we left off on Friday is that we looked at a couple of graphs. We looked at this graph, which was f of x equals 2 to the x power, and we figured out that that was an increasing function. We looked at this graph, which was f of x equals 1/2 to the x power, and that was a decreasing function, and that allowed us to sum up what exponential growth and exponential decay looks like. And so today we are going to be graphing exponential growth and decay using transformations. So a couple of things to notice. When we do transformations, we need to use coordinate points. So we have at least these 3 points to use to help us draw our graph. And we have the horizontal asymptote, which is y equals 0. So we're going to need to use those to be able to do our transformations and find our new points. Notice it doesn't matter whether it's growth or decay. The 3 points are the same, and the asymptote is the same as well. Our points are -1, 1 over b, 0, 1, and 1b. And the b is coming from the base of whatever the function is. So the b is a number. And then once we do our transformations using those points, we can graph our new functions. So let's just refresh our memory on our different transformations. So we can have translations or shifts. So remember, when something is added with the x, it's shifting left or right. A plus f of x plus h shifts left, f of x minus h shifts right. If something is not with the x, it's affecting the output or the y. So f of x plus a number, k is a number, shifts up, and f of x minus k shifts down. We used c when we looked at these before, but this is just a number, h or k. Reflections. We can also have reflections when we have a negative. A negative on the outside is a reflection over the x-axis, and a negative on the inside is a reflection over the y-axis. And then we can also have dilations, which are stretches or compressions. If we multiply by a constant, or in this case, a times f of x, if it's not with the x, it's affecting the outputs or vertical. So a times f of x is a vertical compression when absolute value of a is less than 1, and a vertical stretch when absolute value of a is greater than 1. The reason it has the absolute value of a is because we're only worrying about the number a, not whether it's positive or negative, because if it is negative, that's a reflection. And then if the number is multiplied on the inside with the x like this, f of bx is a horizontal stretch when b is less than 1, and a horizontal compression when b is greater than 1. So all of this we know from section 2D, which we did at the beginning of this semester. So now let's apply it to our exponential function. So the first thing we want to do anytime we're trying to graph with transformations is we need to figure out the parent function. That way we can figure out some points that are on our parent function. So if I look at this function, we're trying to graph f of x equals 3 to the x plus 1 power plus 4. This, because it has a base and an exponent, is exponential. So this one's an exponential function. In this case, the b is 3. So since the base is 3, this would be an exponential growth function. So our parent function here is f of x equals 3 to the x power. So if I find some points on this function, so remember when we're finding a parent function, we also want to find some points on this function. I'm going to use -1, 0, and 1 for my x values. And then remember, to find our y values or our outputs, our f of x values, we plug these in. So if I plug in 3 to the -1 power, so if I plug in -1 for the x, that would give me 3 to the -1 power. And remember, that's a fraction. It's going to be 1 over 3. If I plug in a 0, I'd have 3 to the 0 power. And anything to the 0 power is just 1. And if I plug in a 1, we'd have 3 to the 1 power, which is just 3. So notice this. We always are going to have -1, 1 over b. In this case, b was 3, 0, 1, and 1b. So in this case, the b is 3 because that was our base. So that's always going to be the case like that. So you could either memorize that or you can just think about plugging in your x values to find your outputs. So those are the points on our original or parent function. Now, the other thing we have to include, which we didn't have to include on our previous transformation problems, is the asymptote. On the parent function, the original asymptote is y equals 0. So that's really, really, really important to include. Otherwise, our graph is not going to look the way it's supposed to. All right, so now let's do our transformations. So the first thing I would do would be this expression, which is with the x. Notice it's an x plus 1. The plus 1 is with the x. So hopefully we remember that that's going to be a shift, and that's going to shift the graph to the left one. So the operation I actually do for that, remember when it's with the x, we do the opposite operation. We're going to subtract 1 from the x values only, because this is only affecting the x values. So from my original points, I'm going to subtract 1 from all my x values. So my new x values, this one, -1 minus 1 would be -2. For this x value, 0 minus 1 is -1. And for this x value, 1 minus 1 is 0. So those are my new x values. So far, I haven't changed my y values. So my y values are the same, 1/3, 1, and 3. Now, my asymptote. The original asymptote is y equals 0. Notice, since it's y equals, this is only changing, or this is only affecting the y value. So because the -1 or the subtracting 1 was only affecting the x, I don't do anything to the asymptote yet. So my asymptote is still y equals 0. All right, I still have one other operation. I still have this +4. Now the +4 is not with the x. It's not in the exponent, so I know that's not affecting the x. That's going to be affecting the y values. And so since it is affecting the y values, we just do the operation we see. So I'm going to add 4 to the y values. And that's going to make the graph shift up 4. So if I'm adding 4 to all the y values, this point, since my, I'm going to just write it as 4 1/3. I'm just going to write it as a mixed number, which is fine. So my x values are still -2, -1, and 0. And now my y values are 4 1/3, 5, and 7. This time though, since the +4 is affecting the y values, I do have to add 4 to the asymptote. Since it's y equals, I'm going to add 4 because that's changing the y values. So my new asymptote is y equals 4. So these are my final points. So these are the points I'm going to be graphing here. So my asymptote is y equals 4. So let's draw that in. That's a horizontal line at y equals 4. 1, 2, 3, 4. So it's crossing the y-axis at 4. So draw that in. as a horizontal line. And then let's graph our other points. So this point, -2, 4 1/3 means I go left 2 and then up 4 1/3, which is just a little bit above the axis. -1, 5 means I go left 1 and up 5. And then 0, 7 means I go over 0 and then up 7, which would be right here. And then once I have those 3 points and my asymptote drawn in, I can draw in my graph like this as an exponential growth function. So we've done transformations before. The difference here is that we have a different parent function. We started with an exponential function, but we still find 3 original points, do the transformations, and then draw the graph.